Hi, let's see how to derive length equation. So have a really good look at this is an object kept between f and 2f of a convex mirror at a side. The object having a height of h. The object having a height of h. Right. This is what the image it would form. The image may have a height of simple h. Okay. Now I will mark it like within a notation like A, B, C, D and E. I will consider this point as O and the other one as F. Okay, let's see. Now from AOB right angle triangle, see AO, ABO right angle triangle, this part, and the other one is DEO, DEO, see DEO right angle triangle. These two are right angle triangles because vertical and horizontal lines. Right. I can get equal ratios. How when I get the ratio? Because each of these triangles are equiangular triangle. Not congruent but equiangular triangle. See, this angle and this one is equal because opposite angle. This is 90 degrees, so the remaining will be the same. Okay, how good do I? Now I'm going to get the ratio of DE, that means the height of the image, over AB, that means the height of the object, simple h over capital H. That is equals to the image length, that is V over U ratio, because why? This side and this side will represent the same ratio. Okay. Now let's go for the other result, because from one result we can, because V and U included, not the focal length included of this one. This one having a focal length of F, that is here. So I want to get some expression out of V and U. Heights, it's impossible to measure. So how do? Okay, see this one. The length from D to F is nothing other than V is the total length minus this F is the length for D to F, is V minus F length. So this triangle is also the equiangular. Why? Opposite angles, right angles. This is also the same height, it replicates. See, the height is the same thing here because these two lines are parallel. Okay, how really good look at. This angle is also the same. So the ratio between OF and FB, that means what? V minus U over F, that is the ratio, divided by F ratio of this one to this one ratio, should be equals to this height to this height. These both the same height because parallel lines, H over capital H. Again I get the same ratio. So now I can equal equation number 1 to equation number 2 to get common ratio of the one. So V over U is equals to what? V minus F divided by F. Okay, what do I do is now I'm going to cross multiply it out. V times F is equals to, in a bracket, V minus F times U. So when I expand the bracket, I get the result like Vf is equals to Vu minus Uf. Okay, now I get certain weird result. It's including subtraction and multiplication. If I get one result at a time, it would be really helpful. How to get one result at a time? So I can remove two unnecessary, because you can see VF, VU, UF, two at a time, two different combinations at a time. So what can I do is I can remove two from the equation and leave one out. So how to do it? I can divide this equation by VUF, the equation X. When I divide, I get this result, what? 1 over U equals to 1 over F minus 1 over V. Now, is this correct? Yes, correct. Only for this occasion. Why? See, this is a convex lens I placed here. And I placed the object in between F and 2F. And I have a certain what? Real image in the other side, enlarged one. Only for this condition it may valid. If this is a convex lens, it is not going to valid. If this is a certain image, even from the convex lens, if it is formed like this type of image, virtual image, it is not going to vary. So I need to get this equation in universally applied. It is not universally applicable in these conditions. So it is why, what can I do about that? Only thing what I can do is, I can just include the sign convention to here. When a certain ray of light traveling along the direction of light travel from the lens, those lenses are measured as negative. So from the sign convention, when you measure something along the direction of light, but the opposite to that, it is like you swing upstreaming, you have to spend some more energy, like that, it is positive. So this direction, everything is positive. Now I'm going to include the signs here. 1 over u, it is positive, okay, plus u equals to, as we know, f is minus 1 over minus f minus 1 over u is what? Negative u. Here it is a negative in that direction. Minus v. Okay. Now you can say it became positive in this side. You can remove this one to the other side. Right? So the equation becomes 1 over f equals to 1 over positive v. This minus and minus becomes plus here. So v. So this plus 1 over u, when it reaches the other side, it becomes 1 over v. This looks uglier. You can remember, state over here even. It is correct. It is not a problem. But it is much better if you can rearrange the terms like in this manner. 1 over v minus 1 over u is equals to 1 over f. This is universal application. You can apply this universally here. So that is it for the certain universally applicable lens formula. This is all for the local level. There are some kind of lens making formula and many more. These are not for local level. For the local level, you have this limitation. First of all, you have to remember this sign convention all the time. Listen to me one last time. It is about when the light ray travel along, if you measure something according to the direction of light travel, those lenses are negative, right? In the other side, if you measure something against the direction of light travel from the lens, those are positive. So this is a positive, this is negative. Naturally, this one is also negative. That's it. Okay, all the best. Get your maximum result out of this.